Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to wrap up all the skills with graphing linear equations. Okay? Actually, we're not going to wrap up all the skills, but we're wrapping up this part of the chapter, of the section rather. And we're talking about parallel and perpendicular lines. Now, we're going to learn how to write parallel and perpendicular equations tomorrow, okay? And we're going to use the point slope form for that. But before I teach you how to write them, we got to really analyze and figure out how to determine when and why lines are either parallel or perpendicular. So if you remember from geometry, okay, parallel lines have equal slopes. And the fact that they have equal slopes allows them to never intersect, okay? Since they have equal slopes, they will never intersect. Now, I went ahead and put a little system here of two parallel lines so that you can really understand the nuances of it. First of all, y equals 3x over here. Oh, I love that. Okay, let's try that again. Y equals 3x over here, so my slope is 3. All right, that's my m. And y equals 3x over here, my slope is 3. So whenever you solve equations for y and you see that the slopes are equal, you have parallel lines. That means they're never going to intersect. Now, please notice, though, that the y-intercepts are different. Why is that important to recognize, do you think? Yes, sir. Thank you very much. I couldn't have said that better myself. My boy just said, well, if they had the same y-intercept, then they wouldn't be parallel. They'd be the exact same line. And that's exactly right. So parallel lines, they do have different slope, same slope, but they have different y-intercepts. You have a line with the same slope and the same y-intercept. It's the same line. Okay? So whenever you see that lines have the same slope and different y-intercepts, you're going to have parallel lines. They never intersect. Pretty simple, right? Easy, to the point. Okay. Next, perpendicular lines. Perpendicular lines have slopes that are negative reciprocals of each other. Since their slopes are negative reciprocals of each other, the lines will intersect at one point and are perpendicular. Remember, again, from geometry, that perpendicular means that you create a 90-degree angle. So let's analyze these two equations as well. For my first equation here, I've got negative 1/3 is my slope. And then for my equation over here on the right, I've got 3 as my slope. Well, guess what? Negative 1/3 and 3 are what's called negative reciprocals. How do you get a negative reciprocal? Well, it's quite simple. Let's say you have your original slope here, and then I want to show you the negative reciprocal over here on this side. My original slope, let's say, is 2. How do I find the negative reciprocal? First of all, guys, what's a reciprocal? Thank you. It's when you flip a number upside down, right? You flip it. So negative reciprocal, you literally just flip the number and multiply by a negative. So in this case, my negative reciprocal would be negative 1/2. Excellent. What if I started with a negative 4? My negative reciprocal would be positive 1/4. What if I had a original slope of 3/2? What would my negative reciprocal be? Say that again. Negative 2/3. Yes, sir. You got a question, my brother. Thank you. No, that I don't want to say that blanket statement. The question was, so you're just turning it into a fraction? Not necessarily. What if I had my brother, my original slope was 1/3? What would my negative reciprocal be? No, it'd be my negative reciprocal. Excellent, my man. It's negative 3/1. So I'm not turning them into fractions. I'm literally isolating or finding or locating the original slope. I'm going to literally flip it upside down and multiply by a negative. Thank you, my man. Thank you for your honesty. Okay? Does that make sense for everybody? Believe it or not, guys, as easy as this seems, don't feel bad. This is what gives everyone a hard time. The negative reciprocal. That's why I want to take my time today and make sure you guys really understand what this means. So parallel lines have blank slopes. Guys, parallel lines have blank slopes. Okay, one more time. Parallel lines have equal slopes. Very good. And perpendicular lines have slopes that are negative reciprocals. Thank you. Okay. May we continue? Thank you, my brothers. Okay, so example 1, determine if the given equations are parallel, perpendicular, or neither. Guys, please don't try to be a hero here. Please solve both of them for y. It's that simple, and then compare the slopes, my brothers. So in this particular case, how do I solve for y? Yeah, great job, guys. You divide by 4. Please remember, you know what? I'm going to start doing this for you guys. Remember that when you're dividing both sides of an equation by 4, you got to divide every single piece of that equation by 4. So I'm just going to go like this. Sometimes that seems to help everybody out. Yes, sir, my brother.
You don't divide the 5x.
You do. Okay. Maybe that what I just did here confused everybody. Hold on. You do. You're dividing it by 4. But when you're dividing both sides of an equation by 4, it's kind of the distributive property of division. So this 4 is going to get divided to the negative 5 and to the 12. So sometimes people can visualize it a little bit easier if they say, okay, I'm going to divide 4 to every single term. So I'm dividing it to this and to that. So I don't know if I just made it more confusing or not, guys. What I'm trying to just make it is easy. You tell me, you want me to leave it the other way where there's a 4 over everything? It doesn't. Do you understand what's happening though? It's got to get divided to every single term. You got it, my brother? Thank you, kid. So now I have y equals negative 5/4 x plus 3. So you guys tell me, my brothers, is it parallel or perpendicular? It's perpendicular. Why? Because the slopes are negative reciprocals of each other. Very good. And by the way, that's a perpendicular sign. That's the symbol for perpendicular. Okay. How about B? Okay, I got y equals 3/4 x plus 7. That's great. How do I solve for y over here? Guys? I'm going to subtract the 4x to both sides. Very good. Thank you, my brothers. So I got negative 3y equals negative 4x plus 9. Go ahead. Divide by negative 3. You darn right. So y equals 4/3 x minus 3. Does that make sense? What's the deal here? Are they parallel, perpendicular, or neither? Neither. Very good. Because 3/4 is not equal to 4/3. And 3/4 is not the negative reciprocal, right? These are reciprocals of each other, but they're not negative reciprocals of each other. Does that make sense, my brothers? Okay. Next, how can I solve for this, please? Divide by 6. Thank you. We're solving for y. So I'm going to divide 6 to every single term on the other side, giving me negative 1/6 x plus 1. Tell me, guys, are these parallel, perpendicular? They are parallel because the slopes are equal. So parallel, that's the symbol for parallel. Looks like just 2 L's. It's kind of like an absolute value, but shrunk in a lot more. Okay? It's not too bad, right? Right? You got this. May I continue? Thank you, gentlemen. Okay. Now, I want you to determine the slope of the line that is parallel and perpendicular to the given line. So I'm going to give you this line here. For example, this first guy here is A. And that's the line I'm giving you. I want to find the slope of the line that is parallel to that and the slope of the line that is perpendicular to that. So what do you gentlemen think would be the first step here? Sir. Okay. Okay, so you want to... Okay. He said find the y-intercept. First of all, I'm very proud of you because your brain already said, okay, let me write the equation, right? Super proud of you, and we're going to do that. But remember, we don't need to find a new equation. We're just dealing with the slope here. But since you had the awesomeness to start out that way, let's go ahead and write out the full equation, okay? My y-intercept is 2. That's B. Very good. So my B equals 2. What's my slope, my brother? Yeah, I'm going down 1, 2, 3 over 1, 2. Guys, sorry if it's not perfectly exact. It's hard for me to get it perfectly exact. I mean, because this one looks almost like it's perfect, but it's not. So thank you for that. Okay, so my slope then is, I went down 3 over 2, so my slope is -3/2. Now, if I wanted to, my equation would be y equals -3/2 x plus 2. So great job there. Beautiful skill to have. I'm so very proud of you. However, you're doing too much work here, in my opinion. In my opinion, since all I want you to do is to determine the slope, what I would have done is I first would have found the original slope, and then my parallel slope would also be -3/2. My perpendicular slope would be 2/3. That would be the more efficient way. But again, kudos to you, my man, to know how to write the equation. Because we're going to have that skill. You must have that skill. But I don't want you to work more than you have to. Okay? It's taken me a long time, and I'm still not a master of it. But my goal is to work smarter, not harder. Right? So, great job, though, kid. Okay, my brothers. So here, what's the original slope of this line? Thank you so much. Thank you so much, man. Undefined. Very good. Okay, now, what's my parallel slope? It's undefined. They're equal. Now, let's focus and pay attention. This is the tough part. What's my perpendicular slope? Okay, there is no -0, but darn am I proud of you. You guys in your brain said, okay, this is something over 0. I mean, undefined, right? So what's the reciprocal of that? The negative reciprocal is -0 over 1. But there is no -0, so it's just 0 in this particular case. The perpendicular slope to undefined is 0. Now, why is that? Look, this is a vertical line, correct? Doesn't a vertical with a horizontal create a 90? So if I have a vertical line and that slope is undefined and I want the perpendicular slope, it's going to have to be the slope of a y equals equation, which is 0. Do you visually see it? Does that make sense? Thank you, gentlemen. Next. Okay, what's the original slope here? Well, I got a perfect point here, and I went up 1 over 1, 2, 3, 4. Yes, sir. So my original slope is 1/4. All right, let's knock it out. What's my parallel slope? 1/4. What's my perpendicular slope? -4 over 1. Perfection. Perfection. Yes, sir. Okay, the question was, would I count it wrong if I put -4? Yes, because I don't know what -4 is. Is that my slope? Is that my original slope? Is that my parallel slope? Is that my perpendicular slope? Oh, what you're saying is if you labeled this and you just said -4, would I be okay with that? Yes, because I'm a math person. And everyone knows that every number and or variable is being multiplied by 1, being raised to the power of 1, and being divided by 1. Thank you, my brother. Okay, What's my original slope for this bad boy? Oh, yeah. My original slope is 0. What's my parallel slope? What's my perpendicular slope? Undefined. Think about it, guys. What's going to make a perpendicular here? A vertical line. And don't vertical lines have undefined slopes? Talk to me, gents. How we doing here with this? Yeah, we got one more page. Ready? You sure? Let's do this. Determine whether the lines are parallel or perpendicular. Okay. I wish I could tell you guys that everything in life is beautiful and pretty and everything is meant to be nice and easy and sweet, but it's not. Okay? And SATs and ACT are notorious for trying to trick you. So even though A, I'm pretty sure is parallel, because it looks it, right? We cannot take it for granted. So we're going to have to actually find the slopes of each. So my slope for this first guy, I got a perfect point here, and then I got a perfect point here. So I'm going to go up 2 over 1. So this slope is 2. Then here I've got a perfect point here and a perfect point here. This is up 2 over 1. So yeah, these are parallel lines. Does that make sense? Because I found the slope of each, they were equal, they have to be parallel. Over here, for B, I don't know what the slopes are. Let's see if they're perpendicular. I've got, what did you do here, Morrow? Hard to tell here. Sorry, guys, it's tough. I believe, yeah, from here and then here, and then the next one would be here, I believe. So I went down 1 over 1, 2, 3, 4, 5, down 1 over 1, 2, 3, 4, 5. Okay, that's what it is. So down 1 over 5. So my original slope here for this guy is negative 1/5. Now, over here for this guy, I believe that I've got a perfect point. Looks like, yeah, right here, right? Yeah. And that goes up 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Yeah. So this is 5 over 1. So this slope is 5 over 1. So are they perpendicular? Yes, they are. Now, please, guys, don't take it for granted. One little slight little tiny angle can make it all wrong. May I continue? No? Okay, thank you. What's up? Okay. Yes, sir. So these are perpendicular. Yes, sir. Sure, man. How did I get the 5? Yeah, let's see if I can help you out here, my man. I found here that I said, okay, this is my perfect point, right? So I went up 1, 2, 3, 4, 5 over 1. Then I verified it. I went down 1, 2, 3, 4, 5, going backwards. So it's 5 over 1. Thank you, my man. We're good? Okay. Now, determine whether the lines L1 and L2 that pass through the given points are parallel, perpendicular, or neither. What do you think you'd have to do here to find out if these two lines that go through these 2 points are parallel, perpendicular, or neither? Hold on, guys. Guys, believe it or not, Mr. Morrow is a human being, and he messes up. But guess what? I'm a man, and I accept it, and I fix it. Okay. No worries, guys. Thank you so much. Thank you very much, kid. Appreciate that. Thank you for getting my back. So now we've got x1, y1, x2, y2. And for line 2, x1, y1, x2, y2. So for line 1, the slope will equal negative 5 minus a negative 2 over 3 minus 0, which is negative 3 over 3, which equals 1. Bless you. Line 2 slope is 6 minus 5 over negative 5 plus 4, which is 1 over negative 1, which is negative 1. So are these guys parallel, perpendicular, or neither? Perpendicular. Yeah, 1 and negative 1 are negative reciprocals. So these are perpendicular. Then over here I have my x1, y1, x2, y2, x1, y1, x2, y2. So my y2 minus y1, this is for L1, sorry for not labeling. y2 minus y1 over x2 minus x1. So this is going to be 2/3. And then my slope for line 2 will be y2 minus y1 over x2 minus x1. So this will be negative 3 over 2. So are these parallel, perpendicular, or neither? Perpendicular. Ah, wow, you were on top of catching my mistakes today, and I'm very proud and thankful for that. Thank you. It's parallel for number 1. Thanks, kid. No, yeah, I was right. Why are you messing me up? It is perpendicular. Ah, there you go. Thank you. Does this make sense, guys? All right. Tomorrow we'll learn how to write equations in point slope form. Fun stuff. Please prepare for your quiz on all of 4-4 tomorrow. Thank you, and I hope you learned a lot. Have a great day, and God bless you. Bye-bye.